myself Anil Mahto, lecturer in Inter Marwari College, Ranchi. Today we will discuss crystal field theory. Before this theory, we have to know some fundamental terms related to this topic. In isolated free state, all the d orbitals, that is dxy, dyz, dzx, dx square minus y square, dz square, have same energy and are called degenerate orbitals. On the basis of orientation of d orbitals with coordinate axis, these are grouped into two sets. First, easy orbitals or axial orbitals or evenly degenerate. These are dx square minus y square and dz square orbitals as they lie along the axis, and B, T2G orbitals, that is triply degenerate or non-axial orbitals. These are dxy, dyz and dzx orbitals as they lie in between the axes. Now we will start crystal field theory. The crystal field theory was initially given to explain the optical properties of crystals. In 1950 onwards, this theory was applied to the study of coordination compounds. First, the theory assumes the ligands and metal ions to be point charges. Interaction between the metal atom and ligands are basically electrostatic interaction. Second, the 5d orbitals in an isolated metal are degenerate. The degeneracy is maintained until the metal atom is surrounded by symmetrical field of negative charge. Third, due to different orientation of d orbitals, they face different repulsive interactions. Fourth, when the negative charge is caused by the ligands of complex, the field becomes unsymmetrical and degeneracy is removed. Fifth, the removal of degeneracy of d orbitals leads to the splitting of d orbitals and their energies. This pattern of splitting is defined by the nature of the crystal field. First, crystal field is splitting in octahedral coordination entities. Let us assume for simplicity that in the given octahedral structure, the 6 ligands are located symmetrically along the coordinate axis with the metal atom placed at origin. As the ligand approach, there is an initial increase in the energy of all the d orbitals equally, but as the ligand approach nearer the d orbitals which lie along the axis, that is dz square and dx square minus y square, are repelled in a stronger manner. Thus their energies increases in comparison to dxy, dxz and dyz orbitals which have lobes within the axis. The lower energy of d orbitals form the T2G set and higher d orbitals form the EG set. The energy difference between the two sets is given by delta naught. Significance of delta naught: in a D1, D2 or D3 coordination entity, that is an entity with central atom having 1, 2 or 3 electrons in the d orbitals, the electrons are singly placed in the T2G set orbitals in according to Hund's rule. For D4 entities, the fourth electron has two options. First, it may enter the EG orbital set. Second, it may enter the T2G orbital set. The selection of choices made on the comparative values of delta naught and P, where P represents the energy required for electron pairing in a single orbital, Case 1, when delta knot is less than P, this situation is called the weak field high spin situation. The fourth electron enter the easy set of orbital. Case 2, delta knot is greater than P. In strong field or low spin situation, the fourth electron enter the T2G set of orbitals. Thank you.